Hey guys, Mr. Rysz here. So today we're going to do the second part of chapter P. We are in calculus here, so let's jump to our notes. I'm going to screen share them here right now. So we did the test for symmetry. Today what we're going to do is look at points of intersection and talk about how this stuff relates to real life data. So I'm going to try to use this pen again. Let's see how well it works. See, is it here? Is it on? No, it's never on. It's never on when I want it to be. All right, now it's on. Connected. There we go. Okay. So first off, points of intersection are the points where the two equations touch each other. So in order to do this, there's several different ways to find points of intersection, but probably a tried and true way is to get one of the variables by itself and to use substitution. So I'm going to do that right here. I'm going to get one of the variables by itself. Now, it doesn't matter which one I get by itself, but I'm going to plug it into the other. And you can kind of look for tricks and tips to do this here. It probably is easier to get the like y by itself. Actually, we can get like a lot of different ways. We can get like this y by itself here and take that y and replace it here. We could get the x by itself. So I'm just going to go ahead and get the y by itself here. All right, so if I wanted to get the y by itself, I'll minus the x over. So I'd get a negative y equals negative x squared plus 3. And then to make it positive, okay, we get y equals positive x squared minus 3.
We can put those tools over here.
Pause this video here.
Put chairs. And I think we're kind of low on. Yeah.
Sorry about that interruption there. Okay, so now we got this y by itself. I'm going to take this x squared minus 3. I'm going to plug it into there. So let me change color since we're on to the next step. I'm going to put my work over here. So we would get x minus, not y, but x squared minus 3 equals 1. So if I was going to solve that, or I'd get x minus x squared plus 3 equals 1. Okay, so unfortunately, if we look at this, this is a quadratic problem. We can't just like minus this over and square root it. So I'm going to move everything over to the one side, set it equal to 0. So 0, that's supposed to be a 0. Still getting used to this pen. Equals, okay, move the x squared over. I would have to minus the x over, and then if I minus this 3 over, it becomes my negative 2. So now what we got to do is solve this. To solve this quadratic, we can do two different ways. We can use the quadratic formula, or we can factor it. Let's cross our fingers to see if we can factor it. What two numbers multiply together to give us negative 2, add together to get negative 1. That would be x minus 2 and an x plus 1. Alrighty, so what this means is we actually will have two x answers. We get x equals 2 and we get x equals negative 1, meaning we have 2 points of intersection. So one of our points, so if we're going to make an answer over here, a list of answers, we're going to have it at 2 comma something, and the other point is going to be at 1, negative 1, it should be a negative, forgot the negative sign there, negative 1 comma something. So the last step is, how do we get that something? How do we figure out what that is? Well, now we know the x values. We're going to plug those x values, and we can plug them into anything to solve for y. I'm going to plug it back into this one here because y is already by itself. So if I plug 2 in, what's 2 squared minus 3? 4 minus 3 is 1. So one of these solution points is at 2, 1. Oh, we'll plug negative 1 in as well. Negative 1 squared is positive 1. Minus 3 is negative 2. Negative 2. So we have two sets of two intersection points at 2, 1 and negative 1, negative 2. Now we can always double check this by graphing. We can take out a graphing calculator. We can use Desmos, and that's what I'm going to do next. So if I go to Desmos, actually, let's see if I can split screen this here. Got my notes, that's my Zoom. I'm not sure what you guys are looking at. I'll make sure I do that again. There we go. Got Desmos here. I'm gonna start graphing this, and Desmos is super nice for this. So we got x squared minus y equals 3. There's the graph of the parabola. X minus y equals 1 is a straight line. Move my face. Hey, 2, 1, negative 1, negative 2. That's what we thought. So always easy to double check when we graph. Okay, so let me maximize this. Again, we'll finish our notes here, but this is really what you guys are going to do today, just that points of intersection here. Alrighty, so next, when we're looking at mathematical models, remember if we have a function here, and we got this example, parts of that function is going to be important to us. So this one is just going through, we're going to go through this real briefly because this year's just so different. Just kind of trimming the fat here. But remember, we can use information. So like X and Y intercepts, those are good to tell us where we'd get. So if we're looking at CO2 emissions, the Y intercept would be our starting point. And then any mathematical model, we can take an X value and plug it in to find it. So this will be something bigger that we'll do later on, but we'll go through. So today you guys have the homework. When I print these off, these homeworks aren't going to match up. So I probably won't print off the note page, but you might see a couple of them on there. Okay, guys, hopefully you guys can finish this. Remember, you can retake any of those CYU assignments as many times as you need. Best of luck. Let's end this meeting.